Hey, ladies and gentlemen, we're going to go over a quick analysis of this parent function and how it can be transformed graphically by changing the function itself. So the parent function is y equals x squared. So these are the ways that it can move. It could move up and down the y-axis. It could move side to side on the x-axis. It could reflect over the x-axis or over the y-axis, and it could stretch or shrink vertically. It could also change in more than one way. So in an example like this one, y equals negative x plus n, the quantity squared. This would mean that we move left n, because remember, inside of this operation, a plus n means it's kind of a liar and it moves the other way, not the positive way, but the negative way. So we'll move left n, and because of the negative sign in front, reflect over the x-axis. So two transformations for this function. This function would also have two. It would move right n units, and it would move up g units. I'm not going to go through this list up here. I'd like for you to record that in your notes so you'll have that to refer to as you go through this PowerPoint. So you should really stop this video right now and make sure you have a set of notes that matches this before you go on and watch the rest of this video. So let's look at this. The parent function is in red. So this parent function is narrower. It's been stretched. So when a parent function stretches, then it follows the pattern y equals some whole number value times the function, in this case, x squared. So if you look at the list over on the side, the answer to that is going to be g. This next function shows that we've transformed it upward. So this is a situation where we've had the function transformed upward. So it's moved up, and in this case it's moved up 4 units. So we're going to look for a pattern like this where we have the function plus 4. So when you look for that, you should find that the answer is C. Notice that the plus 4 is outside of the function. It makes it very different from one like this one down here or this one up here. When it's inside the function, it behaves much differently. This kind of a pattern means it moves side to side. This kind of a pattern means it moves up or down. Okay, oh look, here we have another one. This is a parent function in red, and then the function that we're trying to understand is in orange. And it's squished, it's wider. So this is one that is going to shrink vertically, so it gets squashed vertically. So this one is going to follow the 1/2 x squared pattern. Another word for what happens with this one is that it's compressed vertically. All right, so on this one we begin with the red parent function, and the green one has moved side to side. So we're going to look at the side-to-side options. So when a function moves side to side, then the value moves inside the functional operation. So we're looking for a pattern where we show an x squared plus 3 inside the function. Oh, excuse me, I'm sorry, I said this so backwards. Sorry. It's Friday afternoon, I'm trying to do this. Remember with side-to-side functions that this is a liar inside. So since this moves to a positive 3 on this side, then the operation on the inside will be opposite of that. So rather than it adding 3, it's going to subtract 3. So this is the choice right here when we move to the right. Sorry, caught me. Okay. Here's one where the parent function has moved down, so it's moved in the negative direction. So that's just going to be the x squared function subtracting the number that it's moved, so in this case 4. So this should be the answer D. This one shows a parent function that's been reflected across the x-axis. So with a reflection, we follow this pattern. Reflected over x means you're looking for the negative sign on the outside. That would be A. This is one where we have two things that have happened. We've had this function transform by moving to the right, so it's moved side to side, and it's flipped over, so it's reflected. So it's not only moved side to side, but it's reflected. So the side to side pattern that we want to find is, since it's moved to the right, it's going to be a subtraction. So it's moved to the right 3. So we want a pattern that says x minus 3, and it has reflected over the x-axis. So we know that we're also going to look for a negative sign in front of this pattern right here. So hopefully, with that in mind, you've selected this one. All right, here's our last one. This is going to be, well, I think it's our last one. It may not be. I lost count. So in this case, our parent function is also transformed twice again. It has moved to the right, so it's moved side to side, and it's moved down. So we're going to look for this pattern for moving left and right. It moved to the right, so we're going to know that it moved over to 3 units. So we're going to look for subtracting 3 inside this, and it moved down. So we're going, and we notice that it moved down. I can't see it. Yeah, it moved it down 5. It looks, no, 4. We covered it up, haven't we? So that's not right. Oh, yes, it is. Let's go back. Yeah, I just covered it up. So if we look back at that one, x minus 3 squared minus 4. So this moves it side to side, moves it to the right, and this moves it down. So whenever our donut comes up, it covers up part of the function. All right. Here's one where we have a function that moves only side to side. So this is one where we're going to look for only this pattern. This has moved to the left, so that means that we're going to have a positive sign, a plus sign inside this function. So there we go. X squared, x plus 3, the whole quantity squared. Then here's another one that has had two things happen. So this has moved, and it has also flipped. But let's be careful, because if we pay attention to this, this actually moved upward and then reflected. So in this case, we had an x squared plus n to move up this way, and then it reflected. So the answer is this one. It's a plus 4. So this one's rather odd. This moved, because we do the function inside first, it moved up here, and then it reflected over the x-axis. So it's y, or rather j. Y equals the opposite of the quantity x squared plus 4. All right. Thanks, you guys. Go ahead and study these a little bit more. I'm going to have one more set of these that I'll put online. However, I won't narrate that. That'll just go on as a PowerPoint. So keep working on this. We're going to have multiple assessments over this. And always go back to your notes and remember that we're going to paying attention to functions that move up and down, side to side, reflect over the x or y axis, or stretch or compress vertically. Thank you.